Hi everyone, this is Dr. Omar. In this video clip, I will show you how to do data transformation in SPSS, how to correct a not normal distributed data and transform and convert this data to become normally distributed in SPSS. Data can be not normally distributed, or the distribution of the data can be not normal due to several reasons. One of them is an outliers. And outliers are an extreme value in your data that is extremely high or extremely different from the rest of the values within your data. Outliers can have an impact on your data, and this outlier impact can be fixed to reduce the impact on the data. There are several options for handling and dealing with outliers and changing the single score. The first option is to remove the case itself or the score. You do that only if you are sure that this score or value or case is not correct or it has been mistyped in your data. Another option is, rather than removing the case, you can change the case or change the score. To change the score is to find the next highest score, add to it 1. Another way is to replace the score with mean plus 2 standard deviation, or replace the score with mean plus 3 standard deviation. And the third option is, rather than just changing single case or score or value, you can transform the whole data, so that not normally distributed data can be caused by an outliers, and outliers can cause skewness, and you can transform the whole set of the data rather than specific values within the data. So here on the right hand side, we can see that there are two histograms. These histograms, the one on the right hand side, have an outliers that caused skewness of the data. So the data are skewed toward the negative value. So there is a negative skewness in this data due to these outliers. And again, on the left hand side histogram, there is a skewness of the data to the positive side, to the positive value, so it is positively skewed data. So this is the non-normal distribution of these two data can be fixed through different options of transformation to revert these data from being negatively or positively skewed into becoming normally distributed, and thus permitting usage of parametric tests for further analysis of the data. So rather than changing the single score value, you can transform all the data to lessen the impact of a single extreme score. Transformation of all data to correct distribution anomalies, skewness, kurtosis, not normal, or outliers. When you do a transformation, it is an inclusive. You do transform all the variable in all the data you have it with all variables in it. So transform the variable that is not normally distributed in addition to all other variables that are normally distributed. So when you do a transformation for your data, transform the normally distributed one and the non-normally distributed one. So what are the options available for data transformation? First one is the Log10 Transformation. Second one is Square Root Transformation. The third one is Reciprocal Transformation. Log10 Transformation. It can be used for either positively skewed data or negatively skewed data. If you have a positive skewed data, Log10 transformation of all your data can reduce the positive skewness in your data. If you have a data that have a positive number, all your number have a positive value in it, no zero, no minus numbers or negative numbers, then use the log expression, the log. If your data has a zero, you cannot do a log 10 of a zero, so you need to use the equation of adding number 1 to all your data and then doing the log 10. So using the log 10 x plus 1. If your data have a negative number, you have to change this number to become positive. And the way to do that is that you add one or more, 1 or 2 or 3 number that makes the negative number in your data positive. So you do a log 10 on the x, either plus 1 or plus 2 or plus 3 and so on. That convert the negative number into positive. In other hand, if you have a negative skewed data, the situation is a little bit different. For negative skewed data, you need to do a first step before Log10 transformation called data reflection. You need to reflect the data, and reflection of the data is to find the maximum value in your data, add to it 1, then subtract from each individual case or value in your data from this combination of x max plus 1. So log 10 will be performed and done on the reflected negatively skewed data. Now, the second options of transformation is to take the square root of your data. So again, situation repeats itself here. If you have a positively skewed data, using a square root can reduce the positive skewness. If you have a data that are positive, then you use the square x. If your data has a 0 in it, again you add 1 to all your data, to every case of score in your data, and then take the square root for it. And if your data has a negative number, then you add 1 or more number that makes a negative number in your data positive. If you have a negative skewed data and you want to do square root transformation, first of all you do a data reflection, and then you do second step is to do square root on the reflected negative skewed data, and the equation for it is square root x max plus 1 minus x from each individual score in your data. The final options of transformation is called reciprocal transformation or inverse transformation. Again, if you have a positively skewed data, reduces the positive, reciprocal transformation reduces the positive skewness and hopefully convert the data to become normally distributed. So if you have a positive number, then use 1 over x. Divide 1 and then divide it by each individual score in your data. If you have a data have a 0 in it, then use the equation again 1 divided by x plus 1. If your data has a negative number in it, add 1 to any number that makes a negative number in the data positive. If your data is negatively skewed, again, you cannot proceed to do reciprocal transformation unless you do a data reflection. And the data reflection is to find the highest score, add to it 1, and then subtract that from each individual score in your data. And then you can proceed to do reciprocal transformation by 1 divided by the reflected data. Data transformation in SPSS. Data can be transformed in SPSS to try to transform the data from being not normally distributed into normal distribution, as parametric test requires the data to be tested to be normally distributed. And one way or one option that is available in SPSS for data transformation is to use the log10 transformation. And log10 transformation can be used to transform positively skewed data and negatively skewed data. For positive skewed data, the formula we use log10. And if the numbers are in this positively skewed data are positive, then you use the log10x formula. If your data are positively skewed, however, they have in it a zero value, then the equation to use is to do log10x plus 1, as there is no log10 for 0. If your data have a negative numbers and they are positively skewed but they have a negative number, then you need to add 1 or any number that makes the negative number in the data positive. For example, log10 x plus 1 or x plus 2 or x plus 3 and so on and so on. Whichever makes the value of the number shift the value from minus into positive. So I'm going to show you how to do all these log10 transformation for positively skewed data with the positive value, zero value, and negative numbers. And then also I'm going to show you how to also do log10 transformation in negative skewed data of negative skewed data. It's a little bit different from positively skewed data. If you have a negatively skewed data and you want to do a log10 transformation, you have to do 2 steps. The first step is to do data reflection. So to reflect your data. And to do data reflection is to find the maximum value in your data, add to it number 1, and then subtract that from every score in your data. It can be the first step can be done separately, reflection, and then log10, followed by log10 of the reflected data, or the log10 of negative skewed data can be done in one step by using the formula given here below, log10 x maximum plus 1 minus x. How to transform your data in SPSS using the log10, and how to transform positively skewed data that has 0 values in it, and data with negative numbers. I have a data and we want to explore the distribution of this data and to find whether it is normally distributed or not. It is an essential step, and it is in fact the first step for statistical analysis of a data, is to explore the distribution of the data, whether it is normally distributed or not. If it is normally distributed, then parametric test will be used for the analysis. If it is not normally distributed, 2 options available: either to transform the data so they become normally distributed through 3 different functions. One of them transform the data through the log10, or use an unparametric test for analyzing the data. So here in this part, we'll show you how to explore your data, how to transform non-normal distributed data, and how to deal with data that have 0 in it and data that have also negative values in it. So the first step here, I have a column called PS, which means positively skewed. I have already checked the distribution of the data and it was positively skewed. So I'm going to show you how to do that. First of all, click on Analyze, go for Descriptive, click on Explore, reset this. I'm going to move the positive skewed into the dependent list box, and I'm going to take statistic, keep it as it is. If I click on plots, I'm going to untick stem, take the histogram, and then tick on normality plot with tests. And options, I'm not going to do any changes. So if I hit the button for OK, SPSS will generate a table. And in this table, this data shows that these data are positively skewed 0.65, and the standard error is 0.1. And here also SPSS has calculated the test using Kolmogorov, Semenov, and Shabir-Wilk test for normality of the distribution of the data. And as shown here, the data are not normally distributed. The histogram also confirmed that these data are slightly skewed to the right, so it's positively skewed. And so the next phase is, again, with this data, it is not possible to move ahead and do a parametric. We need to transform the data, and we will transform the data using the log10. To do that, you click on transform, then click the compute variable, reset this. So the Spss will generate a new column. It has a variable in it, and that variable is based in computation. So we're going to name that column with log10 positively skewed. Apparently, these data are positively skewed. So we notice here that there is a function group called arithmetics. Click on log10, then move the log10 into the numeric expression box. And we need to do a log10 for these positive skewed data, which between here. And then if you hit the button for OK, what happens here is that Spss has calculated the log10 for this positively skewed data. Whether these data has been transformed or not, I will go and show you how to do that. Analyze, click again on descriptive statistics, click on explore, then move the log10 positively skewed into the dependent list box. Click OK. And again, I will go straight forward for the test of normality. It shows here that once we have transformed the data using log10, the data tend to become more normally distributed, as can be seen here by the two tests, Shabir, Wilk, and Kolmogorov, Semenov. So the data become normally distributed post transformation with log10. If we look at the histogram, see here it is positively skewed. That's before transformation with log10, and this is the shape after transformation with log10. So these transformation of data has corrected the non-normal distribution and become normally distributed. Thus, parametric test can be used. Now, what do we do if you have a 0 in your data, or if you have a negative value in your data? Again, it's the same concept. And these data are also positively skewed. As you can see here in this column, we have a 0 value here at case number 10. And so what we are going to do is we are going to transform these data using log10. But again, to avoid this 0, because there is no calculation for log10, we have to transform these data in a certain way. So we click on transform, compute variable. Again, as we can see here, I'm going to generate a new variable and call it log10 0 for a column that has 0 value in it, or data has 0 value in it. And I'm going to again do log, move the log to here, and I'm going to use the data which has 0 value in it. And so the log10 for 0 will not be calculated, so I had to add number 1 to it, so that the data, so 0 become 1, so log10 can be calculated. So if I hit the button for OK, again, so if I have a positively skewed data that has negative values in it, or negative numbers like minus 3.6 or minus 1, as we can see here in case number 5 and case number 14. And if I want to transform this data, we need first of all to change this minus into positive. And the way to change minus to positive, so to do log 10 in it, is to add to the column a positive number. And in this case, I'm going to add, since it's minus 3.6, I'm going to add number 5 to every case on this column. The way to do that is to go through transform, compute variable, reset this, and then Spss will generate a variable. We'll call it log10 negative number. I'm going to select the log10, and I'm going to move the negative value into the log10. Add to this column number 5. So what does this equation says? Do the log10 for the column labeled negative, add it to each cell in it, value 5. If you click OK, again, Spss is generated, a column has a variable in it, and the negative data has been transformed, and the data has been transformed using the log10. So these are the way to do log10 for skewed data that has no 0 or minus value in it, data that has 0 value in it, and data that has minus value in it. There are several ways to transform data that are not normally distributed in SPSS. There are 3 available options to transform data from non-normal distribution to normal distribution. The first option is log10 square root and reciprocal transformation. For negatively skewed data, to perform log10 transformation, it is a prerequisite to do data reflection. So data reflection is the first step in data transformation. Then, once data reflection is performed, log10 transformation can be done on the reflected negative skewed data. Here in this data view, I have a column labeled NS, which stands for negatively skewed data. I have already checked the distribution of this data using the explore function in SPSS and found they are negatively skewed, and I will show you shortly how to do that. And since these data are negatively skewed and we need to use log10 transformation, the first step in doing log10 transformation of negatively skewed data is to do a reflection. So a reflection is a prerequisite, and it is important and essential step superseding transformation. Once reflection on this data is performed, then it is permissible to do log10 transformation. So the first step is to look at the data and explore them. And the way to do that, click on Analyze, Descriptive Data, Explore, set this, and I'm going to move the data labeled NS to the dependent list, and I'm going to untick, click on Plots, untick Stem, tick the histogram, tick Normality, plot with test. So I'm going to look at the distribution of the data that I have using the histogram, the QQ plot, and the statistical test for normality. 2 tests. If I click on Continue and then click on OK, tables are generated in this output, and the one which is in the middle labeled as descriptive. You can see that these data are skewed and it is negatively skewed, minus 0.65. And if we look at the table below, two tests being used, KS test and Shapiro-Wilk test for testing normality, and those two tests shows that these data are not normally distributed. So there is a skewness in this data and it is negatively skewed. If we look at the histogram, we can see here that the data are clustering to the right and the tail point toward, or the data point toward the negative value. So it is negatively skewed. And if we look at the QQ plot here, we can see the data are clustering above the diagonal line. So these data are, now we establish that these data are not normally distributed and it is negatively skewed. And if we want to proceed to do log10, we have to do an essential prerequisite step called data reflection. And the way to do data reflection is first to determine the maximum value in the data set. And from this table, we can see that the maximum value is 6.12. We're going to use this shortly value. So the way to do data reflection is to click on transform, compute variable, reset this. And here I'm going to label this target variable to generate a new variable. We'll call it data reflection. And to do data reflection is to use the maximum value, which is 6.12. We're going to add number 1 to it, and we're going to subtract the value for each score in the NS column or variable. So in this formula says that the maximum value is 6.12. We add to it 1 and then subtract each value in the data we have, or each score in the data. So if we click on OK, a new column is generated and labeled data reflection. And if we click on analyze again to examine the distribution of this data, and we click on descriptive statistic, explore, and then move the NS to the dependent list, the data reflection to the dependent list, and we are not going to do any changes here. I think I'm going to untick the stem, tick the histogram, and tick the normality plot with test. Continue. Okay. Again, descriptive table is generated. One is labeled need data NS, negatively skewed, and the one with data reflection. Data reflection has really, the data was negatively skewed. When you do a data reflection, it becomes positively skewed, minus 0.65 to positive 0.65. And testing, looking at the histogram, this is for the neat original data, and this is for the reflected data, and as you can see here, it has been reflected. And if we look again at the table, we can see here that data is becoming positively skewed. So now we finished doing the first step in data reflection for data transformation, and if we move to the log10 transformation, so the data now are ready to perform log10 transformation. The way to do log10 transformation is click and transform again, compute variable, reset this, and we're going to call it log10. And to do log10 is to click on the function group arithmetics, select the log10, move it to the numeric expression, and then we're going to do log10 or not on the neat data, on the reflected data. And if I click the button for OK, the SPSS will generate a column for log10 of the reflected data. And I'm going to explore and look at the data for the three: the need data, the reflected data, and the log10. If we move the log10 to the dependent list, keep everything setting the same, and we click on OK, a new table is generated for all the three. Again, as we can see here, if we'll scroll down to log10, we can see that the skewness doing log10 has reduced the skewness from 0.65 to minus 0.65 to minus 0.14. So this is really a dramatic reduction in the skewness. And again, if we look at the test for normality using KS test and Shapiro work test, you can see that log10 has transformed the data, and the data become really normally distributed from the value of 0.2 and 0.6 for both tests. So log10 has really managed to rescue and transform the data from being negatively skewed into nearly normally distributed. So if we look at the histogram, we can see that that's the histogram for negatively skewed data and processed data, histogram for the reflected data, and the histogram for the log10 or the log10 of the reflected negatively skewed data is indicate that it's normally distributed. And if you look at the QQ plot, you can see that all the dots or circles are aligned perfectly onto nearly perfectly on the diagonal line. And if you look at box plot, it is really normally distributed. So we've done log10 transformation on negatively skewed data by doing first data reflection and then second log10. We could do also a step that is combining both data reflection and log in one step. The way to do that is to click on compute variable, reset this, and I'm going to call it again log10 direct. So to do log10 direct is to click on arithmetics, log10, and move the log10 here. Since I'm going to do log10 on the need data, and I'm going to do both data reflection and log10 simultaneously, so I'm going to use the need data. So I'm going to do, again, repeat that, is to do reflection 6.12, add to it 1, subtract from it the value for each score in the data labeled negatively scored. So here now we have an equation that's saying do a log10 for a data that will be reflected. So reflection will be done simultaneously, log10 will be done. So if I click on OK, again, you can see here that the log10 direct has generated, a column has been generated for log10 direct, and the value in it similar to the way that you've done it. So you have done it by 2 steps or 1 step. So there are two-step log10 or 1 step. So there are 2 ways to do the log10 of negatively skewed data. To do first, either to do the data reflection first in a column and then do log10 on this data, or just combine them in one column and do data reflection and log10 in one column. This is the way to do log10 transformation of negatively skewed data. Data transformation in SPSS using square root for either a positively skewed data or negatively skewed data. If you have a data that are not normally distributed, whether it's positively skewed or negatively skewed. Square root transformation is one of the options available to try to attempt to transform the data from being not normal to normal. So square root can be used to try to revert data, transform them to become normally distributed, whether these data are positively skewed or negatively skewed. So positively skewed data can be transformed using a square root. If these data have a positive number, then you use the equation square root x. If the data have a zero value in the scores, then the equation can be used as following: square root x plus 1. So you add number 1 to the each individual score within your data and then take the square root for it. If you have a data that have some negative numbers in it or few negative numbers in it, add 1 or any number that makes the negative numbers in the data positive, like adding 1 or 2 or 3 or 4 and so on, whichever number that can make this negative number positive. However, if you have a negative skewed data, then the situation is a little bit different. You have to do a prerequisite step before you do a square root transformation, and that step is called reflection. So you do reflection first and then you do the square root transformation. And to do reflection is to find out the maximum value in your data, add to it number 1, and then subtract this from every individual score or value in your data. Then you can proceed to do the square root transformation. So square root transformation for negative skewed data is 2 steps. The first step is data reflection. The second step is the square root transformation. I will show you how to transform data in SPSS using a square root formula. And this square root can be used to transform data that are positively skewed and data that have negative numbers in them. And transformation of data is one way to overcome outliers in your data or a data that are not normally distributed. Here we have a data that is positively skewed, as I've already done checking on the data using Explore in SPSS, and I will show you shortly how to do that. I have here a column of a data, and we need to check the distribution of this data before proceeding to any statistical test. So the first step in data analysis is to determine whether the data are normally distributed or not. And if it is not normally distributed, there are few options, and one of the options is to transform the data using square root or other choices. So first of all, to check whether these data are distributed, here I have in this column a PS data that labeled as PS. PS stands for positive skewed data. So to check the distribution of the data, click on Analyze, Descriptive Statistics, Explore. I'm going to reset this, and I'm going to move the positive skewed data to the dependent list, and then I'm going to click at the plots icon. I'm going to untext them, take the histogram, take the normality plot with test, as I'm going to use this statistical test to determine whether the data are normally distributed or not. Click on continue. In the options, we're going to keep the options that it is, no changes to it. So we click on OK, SPSS will generate few tables. The one here have descriptive title. From this data we can see that the data we have are not normally distributed, and there is a degree of skewness, and the data are skewed, positively skewed, as the statistic error for it is 0.1. Now the next table here tests the normality of distribution of the data using two tests, Kolmogorov, Seminarov, and Shaviro-Willick. Again, these two tests confirm that this data we have are not normally distributed. If we look at the histogram of these data, we can see that it is skewed to towards the positive value, so it is positively skewed data. So we cannot proceed with this data using parametric test unless we have to go for non-parametric test. But another way to overcome this is to try to transform this data to see if it is really can revert to normal. And the way to do that is to use a square root. So I'm going to delete this square root of the data. And the way to do that is to click at transform compute variable. In this compute variable, SPSS will generate a new column, a new variable with data in it transformed using the square root. I'm going to call it square root positively skewed data. So, and I'm going to look for the square root function here in this box, and then in the one below it, click on the square root, click on move it to the numeric expression, and then I'm going to square root the data that are positively skewed. Then I'm hit the button for OK, and then SPSS will generate a data, as we can see here, a column, a variable with square root of the positively skewed data. So the next step is to check whether these square root transformed data are normally distributed or not. Then we click and analyze descriptive statistics, then explore. And then in this window, I'm going to move the square root positively skewed data into the dependent list and click on OK. Again, we can see here from this descriptive table that the data that are not transformed, the skewness was 0.65. After transformation with the square root, it is reduced to 0.2. So there is a reduction of skewness. So this data tend to be more normal after transformation. Again, this third table, testing of normality using the two tests, shows that the positively skewed data is not normally distributed. However, when square root was performed in all the data, the distribution of the data become normal, as it's seen here in these two tests. Again, this is the data before transformation with square root, and this is the data after transformation with square root. So in fact, transformation has really transformed the data from non-normal to normal, which allow parametric tests to be done on this data. Now, what if I have positively skewed data, but it has in it a negative value, a negative number, like this one, minus 2.5 and minus 1.3. Can I still do a square root transformation? Yes. And the way to do that is to click on transform, compute variable, reset that, Then I'm going to name the target variable as square root negative, and again I'm going to look for the function of square root, move the square root function into the numeric expression, and then I'm going to square root the data that are positively skewed and have negative number in it, and so there is no square root for negative number. And the way to overcome this is to add to each one of these data value or number in the column for the negative number, which will transfer these two negative value into positive. So I'm going to add number, probably go for number 4. So this formula is going to take the square root of this data after adding number 4 to each cell on this variable. If I hit the button for OK, again SPSS will generate a variable which has a data in it that has been transformed, and the negative values has been transformed into positive, and a number 4 was added to all these cases, and then square root we're taking, and then from that move ahead to the check whether these data are normally distributed or not. So in this video I had shown you how to do square root for positively skewed data and data that have negative values in it. Square root transformation in SPSS. If you have a data that are not normally distributed, i.e. negatively skewed data, and you want to do a transformation on this data using one of the 3 available methods, square root method. To transform the negatively skewed data, you need to do 2 steps. The first one is reflecting the data before transformation. The second one, transforming the data using the square root. In this SPSS data view, I have 2 columns for data. One is labeled PS and the other one is NS. And PS stand for positively skewed and NS stand for negatively skewed data. I had checked these NS data and found that they are negatively skewed, and I will show you shortly how to check the distribution of the data, whether it is normally distributed or not, and then how to do transformation on this negatively skewed data using the square root option, and how to do data reflection before doing the square root, as it is essential to do data reflection on a negatively skewed data, then proceed to the square root transformation. So first of all, to examine and check your data and the distribution of the data, we'll click on Analyze, Descriptive Statistics, then Explore. And I'm going to move the NS data into the dependent list. I'm going to click on the plots and tick stem, tick the histogram, and tick normality plot with test. So I'm going to view the data using a histogram, and I'm going to view the data using a normality QQ plot, and do a normality test in a statistical test in SPSS. So if you click on continue, then click on OK, an output will be generated that had in it few tables and diagrams. Here in this descriptive table for data labeled NS, If we look at the skewness, you can find that it's negatively or negative 0.65, so that's indicate the data are negatively skewed. And the maximum value is 15.35 and the minimum is 1. So if we proceed to the next table, see here the test for normality using two common tests in SPSS, the Kolmogorov-Semenov and Shapiro-Wilk test shows that the distribution of this data are not normal, as it's clearly here indicated. So the data here are negatively skewed. And if we look at the histogram here, you can see that the data are not uniform bell-shaped distribution. However, it is shifted, the data is shifted to the right, and the skewness toward the negative signs. So this data are negatively skewed as the tail is hitting toward the negative values. And if you look at the QQ plot, you can see that all the data above the diagonal line, and also so this mainly data indicate, this mainly diagrams and tests indicate that there is negative skewness in this data. So how are we going to do transformation of this data? As it is negatively skewed, we have to do two steps using the square root. The first step is data reflection. The second one is the square root transformation. So for data reflection, it is an important step, and it is a prerequisite for doing transformation, specifically for a negatively skewed data. So for a negative skewed data, you must do the data reflection. Otherwise you cannot proceed to do any other further transformation. And the way to do reflection is as following. If we click on transform and then click on compute, I have a window here, and I'm going to generate a column called data reflection. And to do the data reflection is as a following. First of all, we need to find out the highest value in the data, and the highest value in the data can be really determined using the descriptive table. It says the maximum is 15.35. So I'm going to type here 15.35. Then I'm going to add number 1 to it, and then I'm going to subtract from this maximum plus 1 each value of the data in the column labeled NS. So here we're going to subtract the maximum value plus 1 from each individual score in this data. And if I click the button OK, SPSS will generate a column called data reflection. And if I examine the distribution of this data, I'm going to click on Analyze, Descriptive, Explore, and I'm going to move the data reflection into the dependent list and then click on OK. So SPSS will generate two tables. One of them is descriptive. In the descriptive, we have here the unreflected data, the negatively skewed, and the reflected data. You can see here that the skewness in the unreflected is negative, and the skewness in the reflected one is positive. The maximum value is the same, the minimum value is the same, the kurtosis are the same. So here again, also the distribution of the data still not normally distributed for both the negatively skewed and data reflection. And if we look at the histogram for data reflection, we can see that now this is the data reflection. Reflected, the data become now more positively skewed as the tail is heading toward the positive value. So reflection has changed the data from negatively skewed to positively skewed. Again, as we can see from the QQ diagonal line, that the data are below that diagonal line. So this data has now been reflected and they are ready for the next step. So it's essential to do data reflection on negatively skewed data. So the next step is to try to transform this data from being not normal to normal. And I'm going to use the square root formula. And to do that is to click on transform, compute variable, reset this, and I'm going to generate a variable called square root data reflection. And to do that is to do square root of the reflected data, click on the arithmetics in the function group. In the box below, square root will appear here. Drag this into the numeric expression box and insert between these the data reflected data. So what I'm going to do here to ask the software to do square root for every individual value in this data reflected column or variable. If you click on OK, the Spss will generate another column doing a square root for this data that are reflected. So to check the distribution of this square root data, transformed data using square root to the original negatively skewed data, click on Analyze, then Descriptive Statistic, then Explore. And I'm going to move the data reflected that has been square rooted into the dependent list box, and click on, and then going to click on OK. Spss now will generate a descriptive data that contain all the three data: negatively skewed original data, reflected data, and square root data reflection. Transformed data using the square root on the reflected data. Again, if we look here at the square root, we can see the skewness now is reduced from 0.6 to 0.1. That is really a huge reduction in the skewness. Thus indicate that this data now probably being transformed to become more normal. So if we look at this test of normality, you can see that the negatively skewed data are not normal, or not normally distributed. The reflection is not normally distributed. However, when you square root the reflected data, the data become normally distributed, as it is shown here by these two tests. If we look at the diagram for the square root data reflection, we can see that these data are fairly now normally distributed. So transformation has transformed the data from not normal distributed to normal distributed. Again, if you look at the QQ plot, you can see most of the data scores are aligned on the diagonal line, and the box plots indicate that there is normality of the data. So using the square root transformation of negatively skewed data has transformed the data from being not normal into normal. This is one of the ways to do square root transformation. First step is to do data reflection, then the second step to do the square root transformation. However, you can there is another method to combine both in one calculation. And to do that is to click on transform, compute variable, and then reset. And I'm going to call this square root 2. Square root 2 direct. The way to do that is, first of all, to click on function arithmetic square root, drag the square root into this empty numeric expression, and then if I want to do square root on the negatively skewed data, again I have to do reflection. So I'm going to do skew and reflection in one formula. So to do square root and reflection, to do the reflection, we've already determined that the highest, as we can see here, the highest value for the maximum value is 15.35. So we're going to type here 15.35, and then we're going to add 1 to it, and then we're going to subtract that from the raw negatively skewed data, the original data. So in this equation, what I'm going to ask the software to do a square root for a data that, and to do a square root following doing a data reflection. And the way to do that data reflection is to take the maximum value, add to it 1, and then minus it from each score in the data. So this is the way to do direct square root transformation on negatively skewed data. If you click on OK, Spss will generate again a column called square root direct, and you can see here compared to the square root data reflection, it is the same. If I want to double check it, I'm going to do explore, and then I will add the direct here, square root direct, and move it to here, and then click on OK. And if I look at now I have a table, should have all the 4 different data, not skewed data, minus data reflection, square root, and then square root direct. Again, if you look at the significance of this test, we can see that the square root direct reflection or square root 2-step reflection and then square root are really has been transformed into become normally distributed. So there are 2 different ways to do square root transform skewed data. The first one is to do a reflection, then followed up by square root, or the other one is a direct one in which you do reflection and square root simultaneously. This is the way to do data transformation in negatively skewed data. Data transformation in SPSS. Reciprocal or inverse transformation in SPSS is one of the options that can be done to attempt to transform data that are not normally distributed, whether it is positively skewed or negatively skewed, and try to transform this data to become normally distributed, i.e. to try to revert the data to see if they become normally distributed, and thus will allow using the parametric test in SPSS. As in statistical tests that are parametric requires data that are normally distributed. And if the data are not normally distributed, there are different ways to handle the distribution, try to transform the data using one of the options, which is reciprocal transformation. So if we have a positively skewed data, the way to do reciprocal transformation, and this data have a positive number, to use 1 divided on the value for each score in the data. Data that has 0 in it can use the equation 1 divided by x plus 1. Data that have negative numbers in it, add 1 or any, add number 1 or any number that makes the negative number in the data positive. Use the equation 1 divided by x plus 1 or 2 or 3 and so on. That's for positively skewed data. For negatively skewed data, it's 2 steps required to do reciprocal transformation. The first step is called data reflection, as you need to do this step for negatively skewed data. And the reciprocal transformation formula is 1 divided by the maximum value or the highest value in the data, added to it number 1, and then use this addition to subtract it from each individual value within the data. So we're going to show you how to do reciprocal transformation for positively skewed data and negatively skewed data. Another way of transforming data in Spss is data that are not normally distributed, or data that has an outliers in it, or data that are positively skewed, is to use a reciprocal transformation, hoping that this reciprocal transformation will revert the data from being non-normal to a normal, which will permit using parametric tests in SPSS. Here I have a set of data in a column labeled PS, and I'm going to explore this data and determine whether it is normally distributed or not, or there is skewness on it or not. And if it is not normally distributed, then we will try to use reciprocal transformation to try to correct these data and see if it is really can revert to normal distribution. First step to do is to check whether these data are normally distributed, and I'm going to click on Analyze, Descriptive, then click on Explore, reset this, and I'm going to move the data titled PS into the dependent list. I'm going to untick stem, tick the histogram, and tick normality plot with test, as I will use the statistical test in SPSS to work out for me whether the data are normally distributed or not. If I click on continue, then click in OK, SPSS generated a few tables, and if we look at the descriptive table, again this data shows that there is skewness in the data, 0.99, nearly 1, and the standard error is 0.2. And the software has used 2 tests, Kolmogorov-Sinrov and Shapiro-Willig test, to determine whether these data are normally distributed or not, and the test shows that they are not normal. Histogram again shows that these data are skewed to the right, so that it's positively skewed. Now, how can I correct these data? So I'm going to use one of the options that is available to transform the data. There are 3 options, one of them to use the log10, another one to use square root, and a third one is to use reciprocal. And to do reciprocal transformation, click on transform, compute variable, reset this, and I'm going to generate a column where the data on the PS column will be computed, and I'm going to call it inverse data. And the way to do inverse is to click on one, then divide this, make a division, and move the data into this. So we will going to inverse this data, and if we hit the button for OK, again data has been generated and all these cell content has been inversed. And to explore whether these data are normally distributed, click on Analyze, Descriptive, and then Explore. And I'm going to move Inverse to the dependent list here, so to compare both. And I'm not going to do any changes. If you click the button for OK, so here Spss have made a descriptive data for both. The positively skewed data, which has 0.99 value for skewness, when we inverse or the reciprocal transformation on the data, the skewness has been reduced to 0.05, which means that these data are now normally distributed. Again, if we look at the test of normality, we can see that for the positively skewed, they are not normally distributed. Once we transformed these data using reciprocal or inverse, the data tend to become more normally distributed. If you look at the histogram, this is the data before transformation, reciprocal transformation, and this is the data after reciprocal transformation. So using reciprocal transformation in this situation has really converted the data from non-normal to normal distribution. And this will allow and permit using parametric test. So this is one of the options available to try to transform the data if it is not normally distributed or if it has an outliers. Reciprocal transformation is one of the methods that can be used in Spss to transform data that are negatively skewed. So when you have a negative skewed data and you want to do a parametric test, you can't proceed with parametric test until you try to resolve the distribution of the data, as parametric test require that the data are normally distributed. And reciprocal transformation, one of the options that can be used to attempt to transform non-normal negative skewed data to normally distributed data. In this data view in Spss, on the left hand side I have a data that are labeled NS, stands for negatively skewed. I had already checked the distribution of the data and found this data to be negatively skewed, so it is not normally distributed. And shortly I'm going to show you how to do exploration of the data and find whether the data are normally distributed or not. So the way to do that is to click on Analyze, Descriptive, click on Explore. I'm going to reset this. I'm going to move the data labeled NS into the dependent list. I'm going to click on the plots and tick the histogram, as I'm going to view the data in a histogram, and also I'm going to look at normality plots with tests, so using statistically tests to determine the normality distribution of the data. Click on Continue, then click on OK. An output will be generated with tables. The one in the middle, labeled Descriptive, showed that there is a skewness in this data, and the skewness is minus 0.73, and the standard error is 0.23. So these data are negatively skewed. And looking at the table below, again, test of normality using these two common tests showed that the data are not normally distributed. So this descriptive analysis established that the data we have are negatively skewed and the distribution are not normal. And to proceed with this data for statistical analysis, if the plan to use a parametric test, then transformation of the data is essential to try to transform the data from being not normal to normally distributed and attempt to revert the data from not normal distribution to normal distribution. So there are few options for transforming the data. So it can be used for parametric test, and those options are to use either log10 transformation, square root transformation, and or reciprocal transformation. For negatively skewed data, to do a reciprocal transformation, you have to do first a prerequisite step, which is called data reflection. The data has to be reflected prior to do reciprocal transformation. And the way to do data reflection is to click on transform, click on compute variable, and then I'm going to label the target variable as reflection. And I'm going to use a formula here in the numeric expression for data reflection. And to do data reflection, first of all, we need to find the maximum value in the data. So here from this table descriptive, the maximum value for the data is 1.26. So if we type 1.26, I'm going to add 1 to it, then going to subtract this from every individual scores within this data. So to do reflection, you find the maximum value, add to it 1, then subtract value for each individual scores in the data. If I click on the OK icon, I get a column in the data view. This column is generated and labeled as reflection. If we examine and explore the distribution of this reflected data, we can see here that reflection has changed the data to become skewness to positive 0.732. So now we've done the reflection as a first step. To do reciprocal transformation is as following. Click on transform, click on compute variable, reset this, and then we call it, I'm going to call the target variable as inversion. And in the numeric expression, I'm going to type 1 divided by the reflected data. So to do reciprocal transformation, 1 divided by the reflected data. Click on the OK. Data view Spss has generated a column labeled inversion. So data has been transformed, and to examine the distribution of this data, I'm going to click on explore and then move the column generated called inversion into the dependent list and click on OK. I'm going to compare the data before transformation, the skewness was minus 0.73. Post transformation, using reciprocal transformation, the skewness is reduced to minus 0.42. And looking at normality test generated by SPSS and calculated by the software, shows here the reciprocal transformation has really transformed the data from being negatively skewed to normally distributed, and thus will permit using parametric tests. Just to mention a point here, instead of doing reciprocal transformation in 2 steps, reflection and then doing the inversion, it is possible to combine both in 1 step. And the way to do that is to click on transform, compute variable, and then I'm going to call that reciprocal direct, is to use the numeric expression 1 divided by the maximum value, which is 1.26, adding 1 to it, subtracting the value in the neat unchanged data from negatively data. So here in this, I'm going to do in reciprocal transformation and data reflection simultaneously on the negatively skewed data. And if I click the button or the icon for OK, a column will be generated. Again, as we can see, the value for reciprocal direct using 1 combined step and 2 separate steps, you can see that the value for inversion is the same. So this is how to do reciprocal transformation in SPSS for a data that are negatively skewed.